All right, Honors Algebra 2, Algebra 2. We're back for video number 2, the final exam review guide on 27. Multiply within the square root. 3 times 27 is 81. X to the third times x to the 7th times x to the third is x to the 10th. Y to the 11th times y to the 5th is y to the 16th. Imaginary 2. Square root 2 of 81 is 9. 2 goes into 10 5 times exactly. 2 goes into 16 8 times exactly. Complete jailbreak. 28, you have hashtag conjugates, so you just need to do the first and last part of FOIL. The 7 times root 5 minus 7 times root 5 will cancel. You have 49 minus the square root of 25, or 49 minus 5, and that is 44. 29, remember if you had that sweet calculator, it gave you that answer right away. Square root of 27 is 3 root 3. The square root of 48 is 4 root 3, 3 root 3, and 4 root 3 is 7 root 3. On 30 through 32, solve for x. Get rid of a square root, you square both sides. X minus 1 is 16, x is 17. Subtract 3 from both sides, and square both sides. X plus 2 is 4, x equals 2. On 32, you're going to add 4 to both sides. Then you're going to divide by 2. Then you're going to square both sides. X minus 3 is 36. X is 39. All right, yes, so do write out the instructions for 33 through 34. State whether each function represents exponential growth or decay, and state the percent growth or decay. There's 33. It's all about that base right there. That base is bigger than 1, so it's growth. Move the decimal over twice, 7.5% growth. If the base is less than 1, like it is on 34, it's decay. You move it over 93.5. If you got a 93.5 on a test, that means you probably lost 6.5%. You subtract 93.5 from 100, 6.5% decay. 35 and 36 are pretty easy. Write each exponential in log form. So on 35, given 5 to the 4th equals 625, that is log base 5 of 625 equals 4. On 36, if 16 to the 1/4 is 2, log base 16 of 2 is 1/4. (37 through 38), write each log equation in exponential form. Log base 2 is 64, 6. 2 to the 6th is 64. If log base 324 of 18 is a 1/2, then 324 to the 1/2 power is 18. That is a very true statement. And on this next one, log 3 of 81 equals x. Log base 3 of 81 equals x. That means 3 to what power gives you 81? And that would be 3 to the 4th power. Gives you 81. And down here, folks, I do not currently on me have a calculadora. So log base 12 of 4 is going to be log 4 divided by log 12, which use your calculator to fill in. If you write it as log 4 or log 12, that's fine. Log 127, or log base 6 of 127 would be log 127 divided by log 6. I know that's 2 point something. Use your calculator for that. Or you can leave it as log 127 divided by log 6. All right, on 42, 42 and 43, write as a single log. This, if I have addition in log world, that means multiplication. This is the product property. It's going to be log of 5 times 3 times 4. That's log 60. Here, log 56 minus log 7. This is quotient property. We were talking about this the other day in a Google Meets help session with Calc. That's log 56 over 7, log 8. 44 through 47, solve for x. If I have log base 8 of 64 equals x, that means 8 to the x is 64, x is 2. Log base x of 27 is 3, that means 3 to the third is 27, x would be 3. Log base 7 of 2x minus 5 is 2. That means 7 squared would be equal to 2x minus 5. 49 is 2x minus 5. Dot, dot, dot. Show that work. X would be 27. And log base 2 of 5x plus log base 2 of 5 equals log base 2 of 124. It's not 5x plus 5 equals 124. Because in the log world, addition means multiplication. I'm going to multiply those two together to get log base 2 of 25x equals log base 2 of 24. That's where I can set 25x equal to 124. And I get x is 124 divided by 25, or 4.96. And we're getting close. 48 through 53, solve for x. Let's get the same base. 81 is 3 to the 4th, and I can set the exponents equal to each other. When the bases are the same, then the exponents must be equal. X is 5 over 2. 49, if I want to get rid of natural log, I need to, and I'm going to tell you what, if you're taking pre-calculus or calculus, this is essential. You have to know this. This is coming up both classes a lot. You have to attach e as a base. E to the natural log of x is just x, so it's just going to be x minus 1 equals e squared. Add 1 to both sides. That is an exact good answer. E squared plus 1. On 50, if you want to get rid of e, because you got x, you got something as an exponent there, you attach natural log to both sides. Natural log of e to the x is just x, so this exponent comes on down. X minus 1 is natural log 10. X is natural log 10 plus 1. 51, we can get the same base. 4 is 2 squared. 8 is 2 to the third. So 4 is 2 squared, and I was raising that to the x plus 2. Power to power, you multiply the powers together. Now my exponents are the same. 2x plus 4 is 3. X is a negative 1/2. On 52, add 1 to both sides first. You have e to the x plus 2 is 5. Want to get rid of e, attach natural log as the base. Or not natural log as the base, attach natural log to both sides. Natural log and e cancel, x plus 2 comes on down. X equals natural log 5 minus 2. Now 53 is the way I showed regular algebra 2, and I think it's the way we're going to do it right now. Especially since my graphing calculator is upstairs. 4 to the x minus 3 is 7. I can write that in logarithmic form. Log base 4 of the answer 7 is x minus 3. Change the base form. This says log of 7 divided by log 4 equals x minus 3. Add 3 to both sides. So that is my answer. In honors algebra 2, we might attach a natural log to both sides. We would have gotten something very similar there. Instead of log, we would have had natural log. Same exact answer. All right, 54. You put 20,000 in an account that will earn 12% yearly. How much will that account have in 25 years? 1.12 raised to 25th times 20,000. I think you can find that. Get that graphing calculator app. You have several weeks to get this into me. You'll be all right. Find 55 and 56. Find any points of discontinuity. Write all that out. I didn't tell you to label it as a whole or a vertical asymptote. All you got to do is set the denominator equal to 0. Tell me what x is not allowed to be. Plus or minus 7 and 55. 56. Set x equal to 0. Set x minus 9 equal to 0. X equals 0 and x equals 9. Make that denominator 0. Make the whole function undefined. All right, folks, I think we are going to end it there for video 2 and going to end here video 3 pretty shortly. This is Yak Math Videos signing out.